Good morning for all of you. As I can remember, for the software engineering lecture, we already did I think we already did two lectures. One is from the introduction, and then the second was about the software process. So here we are going to continue the entire software engineering part, software engineering lecture. But before that, we are I'll just summarize what we talked in introduction. So if you can remember what we talked in introduction part, so the topics which we already covered was professional software developments and the software engineering ethics and also the case studies. So when it comes to software engineering, we gave kind of an definition for software engineering and what are the concerned parts of those, the theories, methods and tools and the professional software developments. Those were few things we just discussed when it comes to software engineering. And then when it comes to software engineering, there was a concern actually about the software cost. Then we discussed how we're gonna measure those software costs and also what are the software costs actually we receive. Here we just discussed those ones. And also when it comes to software products, we discussed that there were two products. One is generic products and the other one is customized products. And what do we mean by the generic products and what do we mean by the customized products? We discussed last few lectures. We discussed on last few lectures and also then we discussed about the product specification with respect to generic products as well as customized products as well. So then there were few frequently asked questions about software engineering. There were few frequently asked questions about software engineering. These are the few questions with the respective answers. So these ones you should know already. So what is software? What are the attributes of a good software? And what is software engineering? And what are the fundamental software engineering activities? And what is the differences between software engineering and the computer science? What is the difference between software engineering and the system engineering? Those are few things. Okay, and then there were few more questions as well. One is what are the key challenges facing software engineering? The key challenges which we are facing software engineering, and also what are the costs of software engineering, and also what are the best software engineering techniques and the methods, and also what differences has the web made to software engineering. So then we move to the essential attributes of good software. Then we move to the essential attributes of good software. So when it comes to essential attributes of good software, from the product characteristic, we had maintainability and the dependability and the security and efficiency and the acceptability. These were few product characteristics which we have to have. If we are saying for an software that it is a good software, then those ones should have these product characteristics. Then we have the software engineering. So again, here we have this definition for the software engineering. And also, when it comes to engineering disciplines, what are the things we should follow? What are the things we should follow when it comes to engineering disciplines and also the all aspects of software productions as well. And then the importance of the software engineering. What are the importance of the software engineering and also software process activities as well. Okay. These are then we talk that when it comes to software engineering, the software engineering is kind of a diversity one. Then what are the applications we should check on these ones? There are a few application types when it comes to software engineering. One is standalone application. The other one is interactive transaction-based application. And then we have the embedded control systems as well. Not only that, we have batch processing systems and entertainment systems, and also we have systems for modeling and simulation as well. At last, when it comes to application types, we have data collection systems as well as the systems of systems as well. Those are kind of few application types. Then software engineering fundamentals. Then we move to the software engineering fundamentals. So when it comes to software engineering fundamentals, some fundamental principles apply to all the types of software systems. Then we had a few fundamentals which we follow those ones. When software engineering and the web, about the web, so there were few things. Again, we will be discussing these ones on chapter 19 as well. Then we just discussed web software engineering as well. So when it comes to web software engineering, there were few considerations we should consider. And at last, for the first lecture, we summarized all the key points. That was for chapter 1. Okay. Then chapter 1 as the first lecture. And also, not only that, to complete on this book, to complete the entire introduction lesson, here we have the remaining part as well, which we have to cover. So when it comes to remaining part, the second topic would be about the software engineering ethics. So the second topic would be about the software engineering topics, ethics. So when it comes to software engineering ethics, so software engineering involves wider responsibilities than simply the application of technical skills. So what will happen here? Software engineering involves wider responsibilities. There are more and more responsibilities than simply the application of technical skills. Because of that, the software engineers must behave. The software engineers must behave in an honest and ethically responsible way if they are to be respected as professionals. If they are respected as the professionals. So because of that, actually, the software engineers must behave in an honest and the ethically responsible way. Ethical behavior is more than simply upholding the law, but involves following a set of principles that are morally correct. So what will happen here when it comes to ethical behavior is more than simply upholding the law, but it involves following a set of principles that are morally correct. So what are the issues of the professional responsibility? Mainly, there are few issues of professional responsibility. One is the confidentiality. Confidentiality. So what type of thing there we have? When it comes to confidentiality, when it comes to confidentiality, there the engineers should normally respect the confidentiality of their employers. So if we talk about this confidentiality, so that means actually the um, engineers should normally respect the confidentiality of their employers. And also, not only employers, they should uh, respect their confidentiality of these clients as well. So these employers or clients, irrespective of whether or not a formal confidentiality agreement has been signed. So that's what there we have with the confidentiality. And then we have the competence. So competence कहता हम engineers should not misrepresent their level of competence. So if we consider about the competence, so this engineers, software engineers actually should not misrepresent their level of competence. So they should not knowingly accept work which is out with their competence. And then intellectual property rights. There we have the intellectual property rights. So engineers should be aware of local laws. These engineers should be aware of these local laws governing the use of intellectual property, such as parents, copyrights, and etc. So they should be careful to ensure that the intellectual property of employers and clients is more protected. And also the fourth point would be computer misuse. Misuse of the computers. So software engineers should not use their technical skills. These software engineers should not use their technical skills to misuse their people's computers. The computer misuse ranges from relatively trivial game playing on an employer's machine. They have given us an example as well. Say to extremely serious dissemination of the viruses as well. And then there we have code of ethics. So ACM and the IEEE code of ethics when it comes to software engineering. So the professional societies in the US, United States, have cooperated to produce a code of ethical practice. There are all of these members of this organization should sign up to the code of practice when they join to these software organizations. So the code contains 8 principles. This entire code contains 8 principles which related to the behavior of and decisions made by the professionals software engineering, including practitioners, educators, managers, supervisors, and the policy makers, as well as the trainees, and also not only that, the students of the profession. What about the rationale for the code of ethics? So when it comes to rationale of the code of ethics, there we have 2 points. So first one would be these computers should have a central and growing role in commerce, industry, government, or else it might be medicine related, the education related, entertainment industry, and also the entire society at a large space. So the software engineers are those who contribute by direct participation or by teaching. So to the analysis, specification, design, development, certification, maintenance, and the testing of software systems are there. These are the entire functions, steps of functions, which we have to consider when it comes to rationally for the code of ethics. So because of their roles, because of each and every role in developing software system, this entire software engineers should have significant opportunities to do good or cause harm. It might be good as well as it might be bad as well. To what? To enable others to do good or cause harm, or to influence others to do good or cause harm, to ensure as much as possible that their efforts will be used for good. Software engineers must commit themselves to making software engineering a beneficial and respected profession. This is an example. Software engineering code of ethics and professional practice. So the ACM or the IEEE's computer system or the CES Computer Science Joint Task Force on Software Engineering Ethics and the professional ethics professional practices as well. They are preamble. So the short version of the code summarizes aspirations at a high level of the abstraction. So the clauses that are included in the full version, the entire clauses which are included in the full version give examples and the details of how these aspirations change the way that we act as software engineering professionals. Without the aspirations, the details can become legalistic and also tedious as well. So without the details, the aspiration can become high sound but empty. Together, the aspirations and the details form a cohesive code. So what will happen there on the software engineers? So software engineers shall commit themselves to making the analysis, specification, design, as well as the development. Finally, we have the testing and the maintenance of software a beneficial and respected profession. So in accordance with their commitment to the health, safety as well as welfare of the public, the software engineers shall adhere to the following 8 principles as well. So what are those 8 principles? First ethical principle would be it should be public. Second one, it should be client and the employer. Third one, it should be product. Fourth one, it should be judgment. And fifth one, it should be management. Sixth one, it should be profession. And the seventh one, it should be colleagues. And also, at last, eight, it is self. So when it comes to public, public means the software engineers shall act consistently with the public interest. And for the client and the employer, the entire software engineers act in a shall act in a manner that is in the best interests of their client and also the employer consistent with the public interest. So as the third one, we should have a concern on the product. So the software engineers shall ensure that their products and the related modifications meet the highest professional standards possible as well. And the fourth one, it should be judgment. What about the judgment? Software engineers shall maintain integrity and also independence in their professional judgment as well. And then we have the management. So the software engineering managers and the leaders shall subscribe to and promote an ethical approach to the management of software development and the maintenance. So this profession, when it comes to profession, this profession is software engineers shall advance the integrity and reputation of the profession consistent with the public interest. So what about the last two? Colleagues and the self. Colleagues, software engineers, shall be fair to and supportive of their colleagues as well. And then, as the final principle there, we have to concern about the self, that is, software engineers shall participate in lifelong learning regarding the practice of their profession, and also software engineers shall promote an ethical approach to the practice of the profession as well. What are the ethical dilemmas? There we have an disagreement in the principles with the policies of senior management, and also there might be a concern that your employer acts in an unethical way. If your employer acts in an unethical way and releases a safety critical system without finishing the testing of the system, then there might be a concern as well. Not only that, the participation in the development of military weapons systems or nuclear systems as well. So, what are the case studies? So, these are kind of few case studies. Here we have a personal insulin pump. So this a personal insulin pump is a kind of an embedded system in an insulin pump which used by diabetics to maintain blood glucose control. Another case study is a mental health case patient management system. There, this a mental health case patient management system is kind of a system which used to maintain records of people receiving care for mental health problems as well. And also then a wilderness weather station. It's also kind of an case study. There we have a data collection system that collected data about weather conditions in remote areas. Okay, so these are the case study facts we have. So the first one, it was insulin pump control system. No? What are the things we should uh, pay our attention? So collects data from a blood sugar sensor and calculates the amount of insulin required to be injected. So what are the data we should collect? So we should collect all the data from a blood sugar sensor, and also we should calculate the amount of insulin required to be injected. And then we should calculate, make those calculations based on the rate of change of blood sugar levels as well. Not only that, then we should send signals to a micro pump, to a micro pump, to deliver the correct dose of insulin. So there we should safety critical system as low blood sugars can lead to brain malfunctioning, coma, or death as well. So maybe sometimes high blood sugar levels have long-term consequences such as eye and kidney damages as well. So the insulin pump hardware architecture. This is kind of an hardware architecture. So here we have the insulin, uh, insulin reservoir and also needle assembly, pump, clock, and the sensor is there, controllers are there, alarm is there, and finally we have the display 1 and display 2 as there. And also all these equipments are connected to the power as well. Then activity model, how the activity model works. So first we read all this data from the blood sensors, and um, then we just analyze those sensor readings, all these data, and then we after reading all these analyzed sensor data, we have the blood sugar, and then we can compute the insulin. After computing the insulin, there we can have the insulin dose as well. So after we have this insulin dose, we have two things. One is pump commands, and the other one is the log dose. So when it comes to log dose, after log dose, there we have the insulin logs as well as insulin logs. So again, once we receive these insulin logs, it will connect it to compute the insulin as well. That circle works as a loop, and then once we compute pump commands, it will move to the pump data, and then it will control insulin pump as well. And finally, it will control the insulin pump. Okay. So that's how the activity model of the insulin pump works. Then we have the essential high-level requirements. What are the high-level requirements? According to this given scenario or the case study, the system shall be available to deliver insulin when required, and the system shall perform reliably, and also it should deliver the correct amount of insulin to counteract the current level of blood sugar as well. And also, the system must therefore be designed and implemented to ensure that the system always meets these requirements. That's about the first one. Okay, and then we have the second and the third one as well. The second case study was about a patient information system for mental health. So there we have the a patient information system, PMS. PMS, it might be called as a practice management system as well. Anyway, here PMS refers to patient information system. So here, after the patient information system, we have this MHC or the PMS. And also here we have the goals which we need to cover. And finally, again, we have the organization, how the organization structure work, and also how the key features of this entire patient information management system works. Not only that, what are the concerns? Since it's a medical records, since it's patient details medical records, there might be few concerns on those facts about the privacy, about the safety. There were few concerns. And at the last, we had the third case study. It was wilderness weather station as well. Now, this one is the entire system of the weather station's environment, and also weather information system also there. That's what there we have for the weather, those three case studies. And then we have the additional software functionalities. We have listed down three main additional software functionalities. One is monitor the instruments, power and the communication hardware, and report faults to the management system. And also then we have the manage the system power, ensuring that batteries are charged whenever the environmental conditions permit, but also that generators are shut down in potentially damaging weather conditions, such as high winds as well. So there we have support dynamic reconfiguration, where parts of the software are replaced with new versions, and where backup instruments are switched into the system in the event of the system failures as well. So at last we have the main key points of the relevant topic. Okay, so that's what we have. That's about for this one. That's about for this one. You can go through with all the slides. So when it comes to software engineering, it's kind of a by heart one. You have to remember, recall these ones to answer the entire paper. So yes, just read always, just read the entire lectures and the cues and these ones again and again, so that you will be able to easily pass this entire lesson course module. Okay, and also I'm uploading all these recordings to my YouTube channel, so please watch all those videos, so then you can easily you can access all these lecture materials. So thank you so much for joining. Uh, next see you on next day. Thank you.